Lake Superior State University is located in Michigan's Upper Peninsula in Sault Ste. Marie. Smaller class sizes allow LSSU to have more of a hands-on approach to teaching and learning. All engineering majors require students to participate in a year-long capstone sequence known as senior projects. LSSU offers degrees in mechanical, electrical, and computer engineering, as well as manufacturing engineering technology and electrical engineering technology. They are now offering a robotics engineering degree with the help of their world-renowned robotics lab. LSSU also offers students the opportunity to work in their manufacturing and electrical labs. Offline Tire Vision Systems, or OTVS, is a multidisciplinary, multinational team comprised of 3 Canadian students, 2 Americans, and 1 Brazilian. The team is comprised of Jaron Rowe, Kellen Korab, Adam Palumbo, and Matthias Fanai, all mechanical engineers, as well as Trevor Trainer, an electrical engineer, and Chandler Messer, an electrical engineering technologist. OTVS has paired with Esys Automation, an engineering and manufacturing system integration firm located in Auburn Hills, Michigan, to create a prototype capable of scanning the full circumference of a tire tread and presenting it as if it were flattened out. The idea is to use a small belt and pulley system to rotate the tire while a line scan camera takes continuous images of the tread and stitches them together. The system must be portable, less than 50 pounds, in order to allow for a single user to transport and set up the prototype at various locations. The system is capable of handling a wide variety of tire sizes, weight, and tires with or without rims. It allows the user to simply select the tire, place it on the rollers directly over the camera. Our user interface is developed to allow the user to have a great user experience and to allow for all levels of expertise to be able to use it. To use the system, the user must simply find the aspect ratio, tread width, and rim diameter variables on the tire tread and enter them into the system. Once these have been entered, the user must simply hit the Run Scan button and wait as the tire finishes its complete rotation and the tire tread image is presented. Once completed, the image allows the user to zoom in and examine the tire tread. With this, the user can also save the image or retake the image by changing the exposure time or variables on the screen. These scanned images allow Esys to further its development into their current tire inspection system. The next steps for the project are to be decided by Esys Automation. This may include refinement of the system or exploration into additional tools or capabilities. Special thank you to Mr. Mark Compton, Mr. Sean Nagler, and Professor David Leach for all their assistance and guidance throughout this process.